Hello dear students, once again I welcome you to KLS Gokti PU College of Commerce and Science Belgavi. This is our lecture number 5th on a topic structure of atom, and myself Mr. Akash Nesarkar, lecturer in chemistry, Department of Chemistry. So let us see the contents of today's class. We will be discussing on the spectrum, that is emission and absorption spectrum. Later on we'll study the Planck's quantum theory and also the photoelectric effect. And lastly, we study the Bohr atomic model. So, what is mean by spectrum? See, the spectrum are of two types. One is emission spectrum and another is absorption spectrum. The emission spectrum are further divided into two spectrum, that is continuous spectrum and discontinuous spectrum. What is mean by the continuous spectrum? When a white light from any source is analyzed by passing through a prism, it splits up into colors from violet to red. Each of these colors is so continuous that this merge into the next VIBGYOR, that is waveguide. इसका मतलब क्या है? जब भी वाइट लाइट एक प्रिज्म के द्वारा पास करते हैं तो वो वाइट लाइट सेवरल कलर में से सेवरल कलर शो करता है. उसी को हम क्या कहते हैं? कंटिन्यूस स्पेक्ट्रम कहते हैं. सो व्हेन वाइट लाइट पास थ्रू द प्रिज्म इट शोज 7 colors, that is violet, indigo, blue, green, yellow, orange and red, that is called as a waveguide, and such a spectrum is called a continuous spectrum. What is discontinuous spectrum? When some wavelengths are missing from the spectrum, it is called as a discontinuous spectrum. Suppose some wavelengths are missing from the spectrum, कुछ ही कलर दिखा रहा है, then it is called as a discontinuous spectrum. Then later on, let us study the line spectrum. Spectrum containing few lines separated from each other by dark space, also called atomic spectrum or line spectrum. So when a light is passed through the prism and if it is giving a few lines separated from each other by dark space is called a line spectrum. Next, the band spectrum. The band spectrum is the name given to the group of lines so closely spaced that each group appears to be a band. It is produced by multi-atomic species or molecules. So band spectrum can be shown by the multi-atomic species or molecules. So band spectrum में क्या होता है? Whenever a light passes through the prism, it gives a multi lines, and those multi lines are so closely arranged to each other it appears like a band, and therefore it's called as a band spectrum. Then what is the absorption spectrum? Absorption spectrum depicts the wavelength absorbed by a species. The wavelength absorbed appear as a lines missing from the continuous spectrum of a radiation to which species is exposed. Each spectral line is characteristic of one electron transition from lower to higher energy level. So simple है. Absorption मतलब क्या? कुछ लाइट को वो एब्जॉर्ब करते हैं. Suppose we are having the continuous spectrum. What is continuous spectrum? When a white light pass through the prism, it shows 7 colors, right? But if we place a cold gas before the prism, then what will happen? When light pass through the cold gas will absorb some lights, and when it is passed through the prism it shows a few lines missing from the continuous spectrum. Means what? Some of the light can be absorbed by the gas, and those lines are missing in the spectrum, and that is called as an absorption spectrum. We will clear this through the diagram. See here, emission and absorption spectra. The first one is the emission spectra. When a hot gas means it will emit the radiation. That is nothing but what? It will emit the light. And when that light is passed through the prism, it gives emission spectrum. Means some radiations are emitted. It will show some lines and maximum dark space. That is called as the emission spectrum. And absorption spectrum, when high density hot matter is passed through the cold gas. So जो भी रेडिएशन और लाइट कोल्ड गैस के द्वारा पास हो रहे, कोल्ड गैस हैव्स द टेंडेंसी टू absorb some light, and then when it is passed through the prism, it gives a dark lines. The dark lines indicates what? Yes, the dark lines indicates what? Some of the light have been absorbed by the cold gas. Some of the light has been absorbed by the cold gas, and therefore it is called as a absorption spectra. इसीलिए हम इसको क्या कहते हैं? absorption spectra, because some कुछ लाइट कोल्ड गैस एब्जॉर्ब करता है और वो एब्जॉर्ब करने के बाद यहाँ पे डार्क लाइन दिखाई देता है. सो देयरफॉर इट इज कॉल्ड एज अ एब्जॉर्प्शन स्पेक्ट्रा. It will emit further colors, but some of the wavelength of the light it is absorbed by the cold gas, and therefore it is called as the absorption spectra. So that is the difference between the emission spectra and the absorption spectra. Continuous and line spectrum. See, both are very simple to understand. See, when source of continuous spectrum, that is any source, when it is passed through the cold gas, the cold has the tendency to absorb the light, and it gives, means this cold gas will absorb some light from this source, and further light it will emit. So emitting lights, it shows the color, and the light which is absorbed, those will show the डार्क बैंड. सो कुछ लाइट की वेवलेंथ को वो एब्जॉर्ब करता है और डार्क बैंड दिखाता है. सो दैट इज कॉल्ड एज अ कंटिन्यूस स्पेक्ट्रम विद द डार्क लाइन्स. कंटिन्यूस स्पेक्ट्रम हमने अभी तो सीखा था. व्हेन अ वाइट लाइट इज पास थ्रू द प्रिज्म, इट गिव्स अ 7 कलर्स विदाउट एनी गैप बिटवीन द कलर. सो दैट इज कॉल्ड एज अ कंटिन्यूस स्पेक्ट्रम. आपको कंटिन्यूस कलर दिखते, उसी को हम क्या कहते हैं? कंटिन्यूस स्पेक्ट्रम. बट when it is passed through the cold gas and then it is passed through the prism, then this bright line spectrum means what? It will absorb maximum wavelength of the light and it emits minimum colors, and that is called as a line spectrum. That is called as a line spectrum. So यहाँ से, so this is the continuous spectrum and the bright line spectrum, remember. Then band spectrum, as I said that, so several bands are so closely related, so closely arranged in a such a way that it looks like a band. Several lines of a spectrums are very closely tightly held to each other, and therefore it is appears or it looks like a band, and therefore it is called as a band spectrum. Are you getting? Yes. Then next one, Planck's quantum theory. So Planck's quantum theory ये कहता है, जैसे भी हमको मालूम है सन से रेज आते हैं, राइट. सो रेज इन द फॉर्म ऑफ वेव्स, वेव्स में आते हैं. ओके, जो भी सन से रेज आते हैं, दोज रेज कम्स इन द फॉर्म ऑफ वेव्स. बट प्लैंक्स क्या कहता है? दोज वेव्स, इंस्टेड ऑफ वेव्स, दोज आर स्मॉल बंडल्स ऑफ पैकेट्स ऑफ एनर्जी. ओके, स्मॉल बंडल्स ऑफ पैकेट ऑफ एनर्जी. और उस पैकेट ऑफ एनर्जी को क्या कहता है? क्वांटम. उस पैकेट ऑफ एनर्जी को क्या कहता है? क्वांटम कहता है. सो प्लैंक्स क्वांटम थ्योरी क्या कहती है? व्हेन अ ब्लैक बॉडी इज हीटेड, व्हाट इज अ ब्लैक बॉडी? विच एब्जॉर्ब, विच द बॉडी विच एब्जॉर्ब ऑल टाइप्स ऑफ radiations. The body which absorb all types of radiation is called black body, and when that black body is heated, it emits the thermal radiation of a different wavelength. जब भी हम ब्लैक बॉडी को हीट करते हैं, it emits the radiation of different wavelength or a frequency. The radiant energy which is emitted or absorbed by the black body is not continuous but discontinuous. जो भी एनर्जी इमिट करेगा और एब्जॉर्ब करेगा, it is not a continuous और डिसकंटिन्यूस, इट इज़ इन द फॉर्म ऑफ स्मॉल पैकेट ऑफ एनर्जी. सो जो भी एनर्जी वो रिलीज करता है और एब्जॉर्ब करता है, इट इज़ in the form of small packet of energy, and each such packet of energy is called quantum or quanta. In case of light, the quantum of energy is called photon. So if we consider a light energy, then it is called as a photon. In case of quantum of energy, it is called as a photon. So the energy of each quantum is directly proportional to the frequency of the radiation, that is E directly proportional to frequency, that is E directly proportional to the frequency, or else E is equal to h nu, where mu is equal to c upon lambda, or mu is equal to c upon lambda, where h is a Planck's constant whose value is 6.62 into 10 raised to minus 27, or 6.62 into 10 raised to minus 34 joule per second. The total amount of energy emitted or absorbed by a black body will be some whole number quanta. Hence E is equal to nhv, where n is an what, integer. So यहाँ पे आपको इतना ही याद रखना है. So जो भी लाइट एनर्जी है, सो उस लाइट एनर्जी क्वांटम में क्या कहते हैं, उसको फोटोन कहते हैं. Each energy it is considered as a small packet of energy, and that small packet of energy is called as a quantum. ओके. सो जब भी हम ब्लैक बॉडी को हीट करते हैं, वो ब्लैक बॉडी थर्मल रेडिएशन ऑफ डिफरेंट वेवलेंथ को इमिट करती है, और जो भी इमिट करती है एनर्जी और एब्जॉर्ब करने वाली एनर्जी, वो कंटिन्यूस नहीं रहती, ना कि डिसकंटिन्यूस रहती. वो किस में रहती है, स्मॉल पैकेट ऑफ एनर्जी में रहती है, और उस स्मॉल पैकेट ऑफ एनर्जी को हम क्या कहते हैं, क्वांटम. उस small packet of energy is called as a quantum. So it is given by the scientist Planck, and therefore it is called as a Planck's quantum theory. The next one, it is also in the particle motion, that is a photoelectric effect. So what is a photoelectric effect? When a light is fall on any metal surface, when a light is fall on any metal surface, the metal surface gets heated and it emits the electrons. It emits the electron from the surface of the metal, and such type of effect is called photoelectric effect. So when a certain frequency of light is fall on the metal surface, the metal surface will emit the electrons, and such effect is called photoelectric effect. Are you getting? Yes. So this is a diagram for photoelectric effect. The light is incident on this metal surface, and this metal surface will emit the electron. Okay. So that is a photoelectric effect. Photo is nothing but what? The photo is nothing but light. Photo is nothing but light. So photoelectric effect, when radiation with a certain minimum frequency strike the surface of a metal, the electrons are ejected from the surface of the metal. This phenomena is called photoelectric effect, and the electrons emitted, जो भी इलेक्ट्रॉन इमिट हो रहे हैं मेटल सरफेस से, उसको हम क्या कहते हैं, फोटो इलेक्ट्रॉन्स. द करंट कंस्टिट्यूटेड बाय फोटो इलेक्ट्रॉन्स, और फोटो इलेक्ट्रॉन से हम करंट जनरेट कर सकते हैं. सो द करंट कंस्टिट्यूटेड बाय द फोटो इलेक्ट्रॉन इज नोन एज फोटो इलेक्ट्रिक करंट. ओके. सो देयर आर फ्यू पॉइंट्स. द इलेक्ट्रॉन्स आर ejected only if the radiation striking the surface of the metal has at least a minimum frequency called threshold frequency. So इलेक्ट्रॉन तब ही इजेक्ट होंगे जब सर्टन फ्रिक्वेंसी ऑफ लाइट मेटल पे स्ट्राइक करेगी, एंड दैट फ्रिक्वेंसी इज कॉल्ड एज अ थ्रेशोल्ड फ्रिक्वेंसी. ओके. नेक्स्ट, the velocity or kinetic energy of electron ejected depend upon the frequency of the incident radiation and the independent of its intensity. So कितने फास्ट मूवमेंट से इलेक्ट्रॉन इजेक्ट हो रहा है मेटल सरफेस से, ये किस पे डिपेंड होगा, द फ्रिक्वेंसी ऑफ इंसिडेंट लाइट. जितने फास्ट लाइट मेटल के सरफेस के ऊपर स्ट्राइक करके उतने फास्ट से ही इलेक्ट्रॉन इजेक्ट होगा. सो इट डिपेंड्स अपॉन द फ्रिक्वेंसी ऑफ इंसिडेंट लाइट. ओके. Third one, the number of photoelectrons ejected is proportional to the intensity of incident radiation. So how many number of photoelectrons are ejected is directly proportional to the intensity. जितनी इंटेंसिटी रहती है लाइट की उतने ही फोटो इलेक्ट्रॉन्स इजेक्ट होते हैं मेटल सरफेस के. हमने अब तक एटॉमिक मॉडल्स में क्या सीखा? थॉमसन मॉडल. तो थॉमसन मॉडल में क्या सीखा? एटम इज पॉजिटिवली चार्ज स्फीयर having electrons embedded uniformly, giving an overall picture of plum pudding or raisin. और वाटरमेलन मॉडल, इसको भी हम वाटरमेलन मॉडल कहते हैं. दिस मॉडल फेल टू एक्सप्लेन द लाइन स्पेक्ट्रम ऑफ द एलिमेंट एंड द स्कैटरिंग एक्सपेरिमेंट ऑफ रदरफोर्ड. सो थॉमसन मॉडल जो भी था, दैट इज़ अ प्लम पुडिंग मॉडल और वाटरमेलन मॉडल कहते हैं, वो फेल हुआ. वो रदरफोर्ड एक्सपेरिमेंट को एक्सप्लेन कर नहीं सका. रदरफोर्ड मॉडल क्या कहा? Rutherford carried out an experiment on the bombardment of a thin gold foil with a high speed positively charged alpha particles emitted from the radium. So Rutherford मॉडल से हमको ये पता लगा कि there is a nucleus at the center of the atom and the mass of the atom it is concentrated in the nucleus, right? So those were the observations we have got through the Rutherford model. And also we have the drawbacks of Rutherford model too. What are the drawbacks? If an electron radiate energy during revolution, Rutherford model में हमने क्या सीखा कि इलेक्ट्रॉन रिवॉल्व हो रहा है न्यूक्लियस, ओके, न्यूक्लियस के ऊपर से रिवॉल्व हो रहा है, इट रिवॉल्व्स अराउंड द न्यूक्लियस, but during that revolution whether the electron radiate the energy or not, it cannot be explained by the Rutherford model. It should also continuously lose its energy and should set up a spiral motion ultimately falling into the nucleus. So अगर इलेक्ट्रॉन continuously रिवॉल्व हो रहा है न्यूक्लियस के यहाँ पे, तो इलेक्ट्रॉन either it should gain the energy or it should lose the electricity, either it should lose the energy. It cannot be explained by the Rutherford. Also, it cannot explain the line spectrum of an atom and the discontinuous spectrum of the nature. So Rutherford ने ये भी नहीं कहा कि लाइन स्पेक्ट्रम है क्या नहीं एटम में. So these are the drawbacks of Rutherford model. Okay. To overcome this drawback, we are having the Bohr model. So there are some postulates of a Bohr model. What are the postulates? An atom consists of positively charged nucleus responsible for almost entire mass of the atom. So उसने ये कहा कि एटम में पॉजिटिवली चार्ज न्यूक्लियस है और पूरी एटम का मास न्यूक्लियस में ही रहता है. इट इज़ कॉन्सेंट्रेटेड इन द न्यूक्लियस. द सेकेंड, the electrons revolve around the nucleus in a certain permitted circular orbits of a definite radii. So रदरफोर्ड ने ये कहा था कि इलेक्ट्रॉन रिवॉल्व हो रहे ऑर्बिटल्स में, लेकिन बोर एटॉमिक मॉडल में क्या कहा गया कि इलेक्ट्रॉन्स रिवॉल्व हो रहे फिक्स्ड ऑर्बिटल्स विथ द डेफिनेट रेडिया. सो जो भी ऑर्बिटल्स है वो फिक्स है और उसकी रेडिया क्या है? डेफिनेट है. दैट इज गिवन बाय बोर. And third one, the permitted orbital are those for which the angular moment of an electron is integral multiple of h upon 2 pi. So जो भी angular moment है इलेक्ट्रॉन का वो किसके बराबर है? इंटीग्रल मल्टीपल ऑफ h upon 2 pi. That is angular momentum. It is denoted by the symbol L. It is equal to mvr is equal to nh upon 2 pi where n is an integer. This equation is known as Bohr quantization postulate. So Bohr's theory satisfactorily explains the spectra of species having one electron, namely hydrogen atom, He plus, Li 2 plus, etc. So this Bohr's theory is applicable only to one electron system or one electron atom. It cannot explain if the atom is having the 2 electron or more than 2 electron. Okay, it cannot explain if the atom is having more than one electron. So we will stop here, and remaining things we will discuss in the next class. Thank you.